Welcome to MRS Bulletin's Materials News podcast, providing breakthrough news and interviews with researchers on hot topics in materials research. My name is Laura Lay. Additive manufacturing offers some excellent advantages when it comes to customising the production of materials. For some applications, developments in the technology can lead to easier, cheaper and more accessible production of materials and electronic components. Semiconductors are manufactured in a clean room, often taking days or weeks to produce. Multi-material printing could take manufacture out of the clean room if the resolution of additive manufacturing can be improved. This challenge has been one focus for a particular research group. They have developed a new method for multi-material printing that uses light to cure the ink, allowing for finer structures to be printed and so obtaining a higher resolution than other printing methods. The ink uses a polymer that has applications in bioelectronics.
We have formulated the first time a conducting ink made of PSS with good resolution. Then we have combined in a multi-material approach, modulating some of the properties of the device. And then we have proved in somehow that the mixed ionic and electronic conductor combined with an ionic conductor as a gel for electrode or EMG has good performance, good signal-to-noise ratio, and good stability.
That was Dr. Antonio Dominguez Alfaro, a research associate in the bioelectronics laboratory led by George de Malaris at Cambridge University in the UK. Antonio has developed a printing method that achieves a resolution of less than 100 microns. This low resolution allows for neuron activity in the body to be determined, since these biological structures have a diameter of 100 microns or less. The team created two inks. One ink is a polymeric deep eutectic solvent, PolyDes, made by combining and heating two salts to form a deep eutectic monomer and adding a photoinitiator to allow the ink to be cured. This ink is an ionic conductor, so can capture signals from neurons inside a biological system. The other ink was based on the polymer PE.PSS, which is commonly used in bioelectronics as a mixed electronic and ionic conductor. This polymer was combined with a cross-linking polymer, photoinitiators, an acrylate, and ethylene glycol to achieve an optimal balance between printability and high resolution from the ink. Its ability to act as an electronic conductor means that ionic activity can be converted into an electronic signal.
It was, at the end, the concept of a mixture of a mixed ionic and electronic conductor encapsulated on an ionic conductor.
The inks were printed onto a flexible substrate so that they could be attached to the human body. The PE.PSS was printed into mushroom shapes, forming electrodes surrounded by the PolyDes, which, as well as offering ionic conductivity, provided adhesion. The research team overcame quite a few challenges to design a working device.
It was particularly difficult to find a formulation where the PE.PSS was stable, and also to find a way to make it adhesive to the skin without losing the performance and the conformation to the skin.
The inks were mixed by hand, and Antonio was keen to develop a method to make ink mixing autonomous. The 3D printed mixed material device was used to evaluate the electrical activity produced by muscles in a person's forearm. Currently, methods of performing this evaluation in clinical settings, known as electromyography or EMG, can involve inserting small needles through the skin. The device was also shown to be stable, showing no loss of performance when used 90 days after it was printed. This research addresses many challenges of applying additive manufacturing in the field of bioelectronics.
We have addressed many problems that was in the literature up to now. And I think with the paper, we got most of them resolved. So multi-material, stability, mixed conductions, a good or interesting application, and also adhesions.
This work was published in a recent issue of Advanced Science. My name is Laura Lay from the Materials Research Society. For more news, log on to the MRS Bulletin website at mrsbulletin.org. Follow us on Twitter at MRS Bulletin. Don't miss the next episode of MRS Bulletin Materials News. Subscribe now. Thank you for listening.